Okay, here we are in page 9, solutions to 34 through 42. Number 34. I'm going to do these first couple, writing out everything, but then moving on to kind of quicker ways of doing it. So here we have the square root. So we're looking for perfect squares that come out. So this is a 25 times 2. Now the x to the 5th, we know the x to the 4th could come out with a good square root, so the x is left by itself. And here, y squared and a y. So this will come out as a 5. Square root of 25 is 5. Square root of x to the 4th is x squared, and square root of y squared is y. So we get 5x squared y square root of 2x y. Those are the ones that stay under there. Now, there is one very interesting thing with this. The square roots, you can really only take square roots of positive numbers, as we're dealing with right now. Real numbers, we're staying in the field of real numbers, and so really you can only take the thing of positive. Sometimes when they come out you have to put absolute values on them, and it's kind of a technicality that we're not going to get into here. We're just going to assume we're dealing with positive numbers and focus on the concept of simplifying the square roots. Number 35. Square root of 27 m to the 8th t to the 7th. Now this is 9 times 3. 9 is a perfect square. M to the 8th is a perfect square and can come out, and t to the 6th is a perfect square. So that is a perfect square. M to the 8th is, and t to the 6th is. So when they come out, we get 3 m to the 4th t cubed. Square roots of the 3 is still in there, and the t is still in there, and those can't be simplified anymore. Number 36. Square root 48 is 16 times 3, t to the 8th t, and v to the 6th. Those will all come out. So we get square root of 16 is 4. Square root of t to the 8th. Let's put the underline of what we're taking out here. T to the 8th is, square root of that is t to the 4th. V to the 6th is v to the 3rd. Square root of 3 stays in there, and the t stays in there. Number 37. Cube root of, now we're looking for perfect cubes. Think about what the perfect cubes are. 1, 8, 27, 64. Looks like 27 goes into there. That's 27 times 2. X to the 6th is a perfect cube, and y to the 12th is indeed a perfect cube. You can take y to the 4th cubed, give you y to the 12th. So the ones that can come out, the perfect cubes, are 27, x to the 6th, and y to the 12th. Gives us cube root of 27 is 3. Cube root of x to the 6th is x squared. Cube root of y to the 12th is y to the 4th. Those all come out of the cube root sign, and we get cube root of 2x is left in there. Number 38. Cube root of 40. So again, we got 1, 8, 27, 64. 8 goes into that. This is 8 times 5. 8 times 5, m cubed m. And y to the 15th is a perfect cube of y to the 5th and has an extra y there. So let's underline what can come out. Cube root of 8 will come out nice. Cube root of m cubed, and cube root of y to the 15th. So we get 2 m y to the 5th that actually come out, and then we get a 5 stays in, and an m and a y stay in. 39. Ooh, perfect 7th. 7th root of 128, u to the 14th, y to the 23rd powers. So we are now looking for perfect 7th. 128 is a perfect 7th of 2, and that's a perfect 7th, but that guy really should be written as y to the 21st, which is a perfect 7th. Y squared is what's left over. So we get 2 u squared y to the 3rd power. That's that guy coming out. And then the 7th root of y squared. Can't go any further than that. Number 40. Fourth root. Let me see, is there a perfect fourth in 80? What are the perfect fourths? We have 1, we have 16 is 2 to the fourth, 3 to the fourth is 81. Ooh, we're already bigger than that. So 16 goes into that 5 times, so 16 times 5. Perfect fourth, t to the fourth is a perfect fourth to that, and y to the 12th is already a perfect fourth. So 16 t to the fourth and y to the 12th can come out because they are perfect fourths. So we get 2ty cubed times the fourth root of 5t to the third. That's as much as it can go. Number 41. Fifth root. Fifth root of, let me see, perfect fifths. 1, 2 to the fifth is 32. 2 to the fifth, 3 to the fifth is 243. So 32, I hope, goes into that. 32, 3 times. This is 32 times 3. And then that's x to the fifth is a perfect fifth power, x squared, and a y to the 10th will be a perfect fifth. We'll have a y squared left over. So let's mark the ones that are now perfect fifths. That guy, and that one. And we get 2x y squared to the fifth power would be 10th, so fifth root gives us y squared. Fifth root of 3x squared y squared. Can't go any further than that. And the last one, 42. Fourth root of, now perfect fourths are 1, 16, 81. So this is 16 times 6 here. Notice we wanted to break this guy up into 32 times 3 when we were doing fifth roots because it has a perfect fifth power in it. Here's a perfect fourth power of 16, so we want to break it up with the fourth power if we can. W to the 8th, W, and Z to the 12th. The perfect fourths that we have then are the 16, the W to the 8th. Notice that we're talking about multiples of 4 because when you do exponent to exponent, you multiply exponents, and that's a denominator, so that'll come out to be 2, 8 over 4. And Z to the 12th. 12 over 4 is 3. So we have 2w squared z to the third times the fourth root of 6w. And that's it.